Hey everyone, welcome to Cloud Masters, a no-fluff cloud podcast giving you tangible tips for navigating the cloud. I'm your host, Matan Bordo, and I'm joined by my co-host, Sam Clark. And this episode is for the data engineers out there. We're going to be covering some mistakes that you or your team might be making that are making your data pipelines cost more than they should. And today we're joined by Jon Osborn. He's field CTO at Ascend.io, and Matthew Richardson, who is a senior cloud architect at DoiT, with a subject matter expertise around all things analytics and data pipelines and data engineering. He was on episode 1 with us already talking about BigQuery's autoscaler. But before we jump into these data pipeline mistakes that are costing us money, Jon, can you explain what you do at Ascend? You're a field CTO. I've never heard kind of a word attached to the word CTO. So maybe explain that, and we can jump to our first kind of mistake that you see people make around data pipelines.
Yeah, absolutely. No, thanks for inviting me. Great to be on, and let's have a great conversation. So the word field really, we put that on there because I spend about 60%, maybe 70% of my time focused on existing customers and my pre-sales customers, and kind of like working in the market to discover like, hey, like these things are going on. Here's how strategically, customers should think about it. And I get to work on cool stuff like how do you adopt new pipeline technology? How do you do like these very strategic topics? So that's the field part of the CTO. I still do lots of tech stuff and work internally with the product team and all that for sure. So
maybe we should also talk about what is Ascend.io? What do they do? Like what makes you a guest on this podcast specifically about data pipelines?
Yeah, no, thanks for that too. It's easy to forget. So we are the world's first intelligent pipeline automation system. So we do end-to-end ingestion all the way through delivery of data, including transformations. And we do it across all the clouds and all the major cloud databases. So Snowflake, Databricks, BigQuery. And so we have a new paradigm for how that works. The software is super mature, and we're accelerating in the market. So that's why you're starting to see the word Ascend pop up a lot on data stuff, frankly.
Yeah.
So does that mean, Jon, there's a shortcut version of this podcast where we just plug in Ascend and everything's done? We don't have to worry anymore.
I mean, so yes, because if you try to build your own pipeline system, right, you can get a little ways down the road, but you're never going to complete it to the way we have it. Like we have a whole team of engineers who do nothing every day except work on pipeline technology. So like if you want end-to-end lineage, like have at it if you want to do it yourself. But sometimes it comes down to a build versus buy, and you should probably be buying that stuff instead of trying to build it. Yeah.
Let's jump into just the first, I don't know what you call them, transgression, the first mistake that maybe the builders are making, right? We'll be platform agnostic here, but what would you say is the first mistake you see?
Yeah, I mean, one of the great things I get to do with my job is spend a lot of time at customers at conferences and that kind of stuff. And we do have a catalog of like the top 5, like, oh my gosh, you're spending too much money, you're taking too much time. So we call those pipeline transgressions. The first one is lots and lots of companies, just across the board, overpay for ingestion. Either they have invested heavily in tools that are moving data into systems, or they have gobs and gobs of people working on ingestion. And kind of my view and Ascend's view of the world is that ingestion is becoming commoditized. There's any number of open source projects. Given a enterprise framework to actually manage those, ingestion should be free. I mean, your data is worth almost zero when you put it in your system because you have to transform it and you have to do things to it and merge it and combine it and put your business rules into it before you can actually use that data and extract value from it. So our mindset is that, particularly for Snowflake and Databricks, that we don't actually charge to ingest into those platforms because you're going to need to add value to it downstream anyway. So ingestion, overpay for ingestion means you're under investing in things like data quality and lineage and governance and frankly, really good orchestration downstream and that kind of stuff. So their side effects are real.
Do you see kind of just all the tools and all the platforms kind of shifting towards ingestion, becoming cheaper and cheaper, kind of like storage where it's eventually $0 just across anywhere?
Yeah, I think in a lot of cases, if you look at what Amazon and Google and Microsoft are doing with their clouds, they're trying to make ingestion easier and easier and to the point where you put your data in like an S3 bucket, for example, and then you could just use it from there as a database. Like ingestion in as a actual functional attribute of your pipelining starts to become really fuzzy, even if it actually exists anymore. So that's why we look at it as like, it's just the start of your lineage. So if you happen to have the start of your lineage in, a bucket that you control, or your lineage starts in some API somewhere or some other SaaS product, that's fine. But we view overpaying for that as a mistake, because it should be near zero cost to pull the data into a queryable environment.
Matthew, are you seeing the same kind of issue with the customers that you're working with? Are they overpaying for ingestion? Are they maybe they're building out and managing their own ingestion pipeline, and they're just doing things like maybe they're not paying $0, but they're still making other mistakes as far as ingestion. Like, what are you seeing there?
So at DoiT, I work with a variety of customers across all clouds, and we see quite a big variety of different ingestion methods across all our customers. So a lot of our customers do use third-party tools that perhaps aren't needed, that perhaps they were brought in under original project planning for different data pipelines they built, and certain ingestion tools may not be needed. So a lot of our customers are overpaying for these third-party tools that are in turn doing operations within each data warehouse type that perhaps aren't needed. So in BigQuery, for example, certain tools perhaps would cost money in terms of extra licensing, and also the way that they're inserting the data into BigQuery. And often BigQuery would have a cheaper way of doing it. So often, this is a common problem we see, and often something we recommend better ways at DoiT to save a lot of money in this respect.
What's an example? Like, can you give me a scenario of like,
Sure.
You don't have to name the customer, but like what comes to mind when you're giving someone a tip about how to avoid lots of ingestion costs, overpaying on ingestion?
So it's around understanding the customer's use case. So I had a customer last week that were using a third-party tool to move data from your PostgreSQL database into BigQuery directly, and they weren't aware of all the options they had in terms of the GCP products that were available, and also other ways that you could just query data directly from BigQuery now using federated queries across the databases as well. So a lot of the stuff that the actions that the third-party tool were making were not needed in that pipeline. There were a lot of steps that they were paying for that they didn't need to in that circumstance. So we were able to give the customer all the options available to them, and we found the cheapest one for them, which I won't go into too much depth on the customer themselves, but there were quite a lot of GCP products we looked at that could solve the problem, and also using some of BigQuery's inherent features. And I've seen the same examples across Redshift and Snowflake as well, where again, it's around the customer knowing what tools are available to them at the cheapest price, and where the free batch loading can come in each data warehouse type. So this is a common example we see every day.
I think that's a really key point that you make, though. I mean, and it's common across, I think, the same discussion we had, Matthew, back in episode 1, is customers often don't understand, and it's no fault of their own. It's just cloud billing is so hard. Options mean pricing in the cloud, right? So whatever you turn on is going to have a cost impact. And so often, I had an example just this week that I worked on with a customer where it was actually working in their favor. Things where, as you use a lot of cloud servers over time, they get cheaper as you do more gigabytes or whatever you're doing. And they didn't realize that. So they actually viewed it as a spike in their account at the start of every month, rather than things dropping off towards the end of the month because of that volume tiering. So understanding what your options are and what you're paying for can be a really hard thing to do. So next time I've got one of those at BigQuery, I'm calling you.
Yeah, maybe a topic for another podcast, but having that financial transparency, like observability of like how much your pipelines cost, like what components are actually driving that cost and all that. Driving that is really important, because if you can't measure it, then you can't optimize for it, for sure.
You're a man after my own heart, John. I'm big on FinOps.
I mean, this is a key feature of a lot of our cost optimization sessions that we offer at DoiT International. We do look into our customers' environment, and we look at every facet of data pipelines to work where they are using money they perhaps don't need to. Because one thing with BigQuery, for example, sometimes just reading the documentation and seeing the free loading methods that you have in BigQuery is the best way to go about things, make things as simpler as possible for the customer. You don't have to bring in 4 tools to do a simple job that can be done by one.
Did he just say RTFM, Matan?
Yeah, right. Well, you can. Oh, by the way, John, this is a swearing podcast. We'll just cover your swears. We'll bleep it out with dolphin noises. That's what we landed on. I'd do it.
That's hilarious.
You don't have to.
You don't have to, but he just,
I mean,
he
a whole
used an
podcast
acronym.
of dolphins probably isn't good, but
Yeah. Let's jump to the next mistake. And I think, Snowflake's a popular tool. I think if I recall this one, it's kind of Snowflake centric, but I think it applies just not with Snowpark, right? It applies in different ways to other tools.
yeah, I think so. The specific transgression is that we see lots of customers come to us who are using like Spark, for example, with Snowflake. That ends up being not only 10 or 50 or 100 times slower and less performant, but also more costly than using Snowpark. And so the point isn't that Snowpark is better or worse. The point is, like, these cloud database compute vendors, all of them included, oftentimes have very native ways to execute jobs that are really, really close to the data and within the compute environment that they're offering. So oftentimes that means 2 really important things. One is performance. In general, you'll get much, much more performance out of that. But the second thing is it'll generally cost you less to push that into a single vendor versus running your own infrastructure and trying to use, like, Snowflake, for example, as a database instead of actually using it as a Python execution environment through Snowpark. And I've seen transgressions across all those databases where some legacy architecture came to play and they swapped the database out, but didn't really consider, like, where are we running these jobs? Is this compute environment the right place to run it? And then having the method and the technology to move that compute into the right environment is super, super important. So it's one of the things at Ascend that we focus on is letting customers move, or helping customers move workloads from one compute to another in hopefully a seamless way.
Snowpark specifically for Python workloads, I would say, what are the common issues that you see developers face with Python jobs and Python development? And I don't know. I don't think incorporating Snowpark, is that a walk in the park, or are there some things that people should keep in mind when they're doing so?
I mean, walk in the park is relative. I think the way
I just wanted to make a pun.
It is like, yeah, is a walk in the park. Yeah, right. But the reason, Python's important because sometimes you have to do stuff in a pipeline that is hard to do with SQL or impossible. Like, I need to call an API and pull some information in the middle of the pipeline, or I want to execute an LLM model, or I need to do something where the simplest, easiest way to execute that is in a Python runtime. There's other languages, but let's just talk about Python. So that means that pipelines are rarely a single language, right? And the same is true for SQL. Some things in SQL are just super easy. So why are you using Python to do, like, a simple join and stuff, right? Like, just do that in the native languages that are best for those. So being able to go back and forth is really important. And then also being able to orchestrate across all of that is a giant challenge also. So lots of companies get stuck. I just was talking to a customer last week. They got stuck in an environment because their orchestrator could only orchestrate one type of job, and they couldn't actually move it into the more appropriate environment because the orchestrator wouldn't let them do it. So it's like, well, like, these are problems that come up where customers learn how to live with them, but they end up costing tons of money, tons of time, and hamstringing your development at not only velocity, but ability to deliver. So these are really important transgressions that I see all the time, and I get really excited when I see them, because it's like, all the opportunity exists for you to move this and get, like, literally 10 times faster overnight. So it's a little easier said than done sometimes, but very true.
Yeah, I mean, this is something we see quite commonly as well at DoiT International, again, with, again, customers maybe being less familiar with some of the options available to them in data warehouses such as Snowflake. Like, I mean, I've had a few Snowflake customers recently where Snowpark has been quite a useful feature that a lot of the Python developers in the team perhaps were unaware of, and they thought they'd need to keep their Python workloads for ML a bit more separate to what they've got running in the data warehouse. So the introduction of Snowpark to a lot of customers is something that we've talked about with a few of our Snowflake customers as well. So it's been definitely an exciting transgression to see. But like I say, always something where, again, the customer perhaps can be educated on the use of Snowpark, and something we do a lot at DoiT. And it's the same with BigQuery as well. You do have Python SDKs as well. It can be used with BigQuery as well. So I've seen a few customers, again, using Python with BigQuery environments as well. So it's something that, again, we see a lot of tickets for. And it's always a good problem to solve.
You mentioned, John, about having multiple languages in a single pipeline. So me as the guy that doesn't know much about data pipelines, I don't know what data is, but does that mean that you're going to do something like, you mentioned pulling data from an API. So maybe I'm going to take some stuff from an API, insert it into a database, then do a join with SQL, then bring it back and do some processing in a sort of a data frame type setup with Python. Is it that kind of thing that we're doing it?
Yeah, or even in the middle of the pipeline. So let's say you have a list of customers that are coming in on some flat file or something, some ingestion you're doing, right? But then halfway through the pipeline, you need to pull their LinkedIn profile data, or you need to go to look and see if they're in Google or whatever. And those are going to be REST API calls. So in the middle of a pipeline, you may actually want to make a bunch of REST calls and take that data and then also combine that with the data that you already have in the pipeline. So that's going to be done really, really easily in Python, frankly. If you try and do that in SQL land, it's going to get really ugly really quickly. So that would be a case where, your normal work in SQL is just fine, but branching out into Python is going to save you a bunch of time and also make it possible to have a cleaner pipeline that actually matches your business outcomes. So you don't have these one-off things where this job has to finish and then I got to run my batch for all my LinkedIn stuff while I wait, and then I got to wait, and then I restart later. Putting that all in one pipeline means you get parallelism and all that kind of stuff going that you can take advantage of for sure.
Let's jump to number 3. What's the third mistake that data engineers are making around their data pipelines?
Yeah, the third mistake is something that I think a lot of maybe mid and later career engineers already know, which is you got to use partitioning. And I see lots of reasons why. Well, real quick, partitioning, when I say that, just so we're all on the same page, what we mean is we're breaking up some data into some logical groups. So if you have retail data, you might partition that data by date of sale and store number, for example. So then each store number sale combination is a partition of data, and you're going to process that partition in your pipeline using that paradigm. So I see lots of customers not using partitioning, and for a couple really solvable reasons. One is they just don't know. It's amazing to me how many people don't understand how partitioning can help them in the cloud. And I think the reason for that is they maybe came from a traditional relational database like SQL Server or something, where the partitioning is just a physical storage thing. It's not an actual data processing partition. They relied on indexes and things. Well, those paradigms in the cloud kind of go away. Like Snowflake has no indexes. You just don't do it that way in that world. So they just don't understand or know how partitioning can work. The other issue with that is, even if you want to use partitioning, if you're writing your own software, it's hard to do. It's hard to do well. It's hard to make it adaptive. It's hard to figure out the right way to do it. And if you're not doing it the right way, to change it, it's just very difficult to do partitioning well in a pipeline. I mean, any one table you can partition, but as you pick up that data and you want to move it downstream and you want to do aggregations and you want to do business logic and you want to use that partition in a very effective, efficient way, that's where the trouble starts for lots of not only homegrown pipelines, but even pipeline technology that just doesn't do native partitioning very well. So this particular transgression ends up costing customers a lot of compute credits because they're essentially unnecessarily processing data that doesn't need to be processed. So if you have old partitions that haven't changed, like my retail calendar closes every day and yesterday's transactions are frozen, if I keep processing those transactions every single day as I go forward, I'm essentially consuming credits for no reason whatsoever. So introducing partitioning can not only shorten the time because you're processing less data, but will then, of course, lead to a vast number of savings and credits as your data grows, and also keep your costs flat over time. So,
yeah, we see it with BigQuery too. We have like a little tool that gives recommendations on BigQuery, and one of them is partitioning tables. And we see lots of recommendations, a lot of potential savings around that a specific recommendation. So I don't know if all those people are also coming from the SQL Server background, or they just, there's a lot of things to know when you're managing a data warehouse, when you're managing costs like that. But it's also like, isn't it also like there's certain types of data sets that are good to partition? There's using proper partitioning keys, a lot of things to understand there, right?
Yeah, and this is true of virtually every data warehouse type. I mean, even with Redshift, you have sort keys and distribution keys as well that need to be strategically picked. But like you say, Matanya stole me thunder with the BigQuery Lens recommendation in terms of partitioning is pretty much one of the big recommendations there in terms of in BigQuery. Setting the right partition key prevents too much data being queried than what needs to be queried in each query. So the amount of savings we see on BigQuery bytes scanned is massive when the partitioning is set correctly. So it's the same with BigQuery as it is in Snowflake as well, with your example, John, as well, of how partitioning works in Snowflake with Snowflake tables as well. So yeah, this is a big saving for our customers as well, and also things like clustering as well in BigQuery is another factor as well. So yeah, this is one of our biggest cost optimization factors usually.
I think it's also one of those things, and again, me not the data guy, but the things that I do notice happens a lot is as particular as cloud native businesses grow, as they're sort of making their first entry into the cloud, and then their data sets start growing and growing and growing. It's something that the bill just creeps up on you, right? And sometimes you don't realize that, hang on, if I go back and change this now, that's going to save me a lot in the future. It's not always a case of people don't know what partitioning is or how it can help. It's just that they never thought of it because they were busy focusing on other stuff or whatever it is, And so I think hopefully, this kind of a podcast might serve as a little reminder to those people to go and have a little look and see if some partitioning needs to be set up on their data.
Sometimes the customers may not know the query patterns on the tables as well. Like in BigQuery, for example, if you've got queries that are regularly querying one field, then partitioning on that field or clustering by that field can be a massive saving overnight. And sometimes the customers don't know what the other teams are doing with their tables, perhaps, and maybe there's opportunities they don't know about. So this is quite a common theme we see where they're not ignorant of partitioning, but they don't know the opportunities that are on certain tables.
Is the flip side true of BigQuery? I know this was a big issue with customers that I had in a different in AWS before, where the performance would suffer because you would end up with hot partitions that were constantly getting queried and other stuff that maybe needed a bit more balancing, things that you did need to regularly query, but because maybe you were using logs and querying indexing by the date, you're always querying the latest thing, so your performance goes down as well. Is that a thing that we need to take into consideration in an analytical system more like a data warehouse?
I mean, in BigQuery itself, if you partition by a field that has very large amount of values within one partition, in theory, it shouldn't make a big difference to the query because you're still scanning less data, because BigQuery works by the amount of data it's scanned. If you haven't got a partition, it will scan the full table each time. Whereas if you partition by something that made up 90% of the data, perhaps, it would scan 90% of the table, but then you're probably not seeing the benefits of the partitioning because then you're adding more metadata, you do things there, so you may see lack of benefits there, like it may not be worth partitioning a table that's maybe 10 megabytes or has got 10 records in there. You're just not going to see the saving from the query perspective or the byte scan. So yeah, there is that factor to take into place. But as John was saying as well, I mean, some tools have better settings where you can add partitions into them than others. Like, I mean, some people may not like to just manually add partitions to the tables, they need a tool that makes it easier to add the partition in the cluster. So that's where some tools are better than others in that respect.
Yeah, at Ascend, we take the observability approach to partitioning, which is like, partitioning is awesome, but let's not get wrapped around the axle of getting everything perfect. Let's look at the pipelines holistically and look at your entire environment. And like, here's your top 10 queries that are costing you the most. Do you actually care? One. And two, if you care, then let's work on those. And then let's iterate through the list until you're okay with whatever your costs, your compute costs are. And then let's track it over time to see if it changes. Like if, to your point, Sam, if it's growing really steeply, that might be a problem, but maybe normal growth is, $100 a month or something, which would be awesome. And that's okay. So let's track it and let's watch it and observe and then use that to inform our activity. So we're not unnecessarily, to Matt's point, partitioning a million record table probably is not something you should worry about. Like you got other problems to worry about.
Jon, I heard one of your engineers say that I've talked about managing the relationship between partitions and how that's important, at least in the context of data pipelines. I'm also not a data guy like Sam. What did he mean by relationship between managing the relationship between partitions, and why is that so important?
Yeah, so that's a great question, and it's a nuance, and it's it's a tripwire for lots of people too. So let's contrive a quick example. So let's say we're partitioning by day, and we wrote our pipeline to give us total sales by day, but then we want to actually have data changing in other partitions, and we want to get a total across multiple partitions, but they're not even. So now I want sales for lunchtime to lunchtime tomorrow. So it's crossing a day, and now I have half of one partition and half of another partition, and I write a query that way. I'm going to get the wrong answer essentially if I look at it that way, because I'm only going to include half the records from each partition. So you can get into these scenarios where partitioning is going to give you answers that you didn't expect. So it's always important to understand your business outcome and like, what is it? What granularity do we need to see at the end of my pipeline? What are my business users or consumers of my data looking at? And then what partition strategy is going to get me the best performance across the pipeline, but also make those end results accurate without violating any of these sort of, let's call it level 201 or 301 class level partitioning strategy tripwires. So it can be really interesting to figure that out, but it has to start with the business outcome.
Got it. Well, if no one has anything else to add to that one, let's jump to the next mistake/transgression.
Oh, this is one of my favorites. So, and I came from this world too, rerunning the whole pipeline. And this is like the throw the arms up in the air scenario where, I have a few dozen or 100 pipelines in production. We made a bunch of changes and now like to the logic, but now we don't know what tables what jobs need to be rerun, what tables need to be updated. Like we don't know. So it's like, oh, well, we don't want to take the time to figure it out. So let's just rerun everything and like get it all up to date. And that works like, in a pinch for sure. Theoretically you get the right answer and you're good, right? If you're doing that every day or every week or every deployment and your data is scaling over time, that is going to be more and more and more costly over time because you are rerunning ingestions, you're rerunning transformations, you're redoing business logic where the input hasn't changed and the logic hasn't changed. So the outcome hasn't changed. So that particular query gives you the same exact result every time you run it. So having a tool, Ascend being one of them, or maybe even the only one, where you can go into the middle of a pipeline and make a change and have that propagate downstream through hundreds or thousands of other downstream dependencies, but not touch anything to the left, i.e. things that you've already ingested or business logic you've already processed. That could lead to not only significant savings, but also time savings too, so that you're not redoing work that is useless. So we call that intelligent consumption. So if I'm going to spend a credit on, Snowflake or Databricks or BigQuery, like I want that credit to actually result in a change in my outcome. Like I want some value for that. I don't want to just run compute to run compute. I want value.
It's that quote about doing the same thing a lot of repeatedly and expecting something different.
Yeah, right. Or expecting your cost to stay flat. Yeah, right.
Yeah.
No, it's not going to happen. So like having mid-pipeline restarts or having the ability to deploy to production across thousands of pipelines and have your tool actually figure out which components need to react to that deployment and which ones don't. That's really, really valuable, but also nearly impossible to do if you're writing your own software. It is very technically challenging.
Basically, building a self-aware pipeline that knows when to retry and that understands the context of the errors. If there are errors, you said there's just updates.
Yeah, we call that data aware. So that our code, at least at its end, the code and the data are aware of each other. So if either one of them is perturbed, either a partition gets changed or business logic element changes, the orchestrator will then figure out how to rectify that change by rerunning queries or doing what it needs to do that in the most effective way.
Matt, do you see customers doing this, rerunning the whole pipeline, or have you seen any like novel ways to try to tackle this without a third-party tool?
So quite regularly we see this problem. I mean, speaking from the Google perspective again, I mean, there are tools that can be used within the GCP infrastructure, such as maybe implementing some logic in data form, perhaps, with some of the jobs that are running in BigQuery. And there is logic you can put into your BigQuery jobs to maybe stop them from processing certain elements, but it is a bit more of a bespoke problem. A lot of our customers do regularly run the same queries every day. We do have that recommendation in our CMP console as well, where there are certain queries in a customer's environments that maybe are run too much, and some of them are often the queries that are probably not needed because they've already they're processed in the pipeline once. They only need to process once every day. So this is a common problem we see, and a lot of costing there. But then there is things that you can do to get around things as well. There's also a lot of caching features as well that can be used as well for regularly repeated queries where the result's going to be the same in a lot of data warehousing structures. So this is something that, again, we need to help the customers with quite often. And like I say, we see this across BigQuery and Redshift cases as well, where often it's a case of being a bit cleverer with the tool that you're using to orchestrate your pipeline to start from a particular perspective. And sometimes that means adding bespoke logic into a pipeline that the customer's running. So it all depends on the customer's use case and how they're executing the pipelines.
It's also it's a nuance, but not a nuance too. Lots of people, including myself and engineers that have worked for me in the past, went down the path of creating views and things as sort of pipeline elements. But Matt mentioned caching, and you lose that ability now. Every time you call a view, you have to actually run a query to actually data. So actually, sometimes physicalizing every step in the pipeline, although it takes a little bit of storage, has two great side effects. One is if the data isn't changing, the data is not changing. So there's no cost. And two, like storage is around 10 times or more cheaper than compute. So if I was biased towards storing stuff and avoiding compute, that would definitely be less expensive. So leveraging all of that together in a framework that lets you build a pipeline in that way has a dramatic impact in how you manage data going forward through pipelines, especially when you get to scale. When you have thousands of pipelines, the leverage there really matters.
Yeah, I mean, that's a good point. I mean, we do often recommend that our customers do materialize a lot of elements of their pipeline so that, like you say, if there is any rerun needed, that the same logic doesn't need to be reprocessed, or at least won't cost them any money. So a lot of it is around incrementalizing your pipelines to make sure that, you're only running the new data through, that you're not rerunning steps that have already been run. So a lot of the time that can be done with different derivations of different table types in whichever data warehouse you're using.
Yeah, and my favorite customers are the ones that have multiple warehouses and multiple clouds. So actually watching that happen from Snowflake to Databricks and then into BigQuery all as a single pipeline is pretty amazing. That's a little mind blowing too.
Sorry, you're in real time blowing my mind. People ingest data from Snowflakes to Databricks to BigQuery for fun. I mean,
No. They may have their marketing data in BigQuery, which is really common. They may do their data science workloads in Databricks, but then their warehousing's in Snowflake. It's a super common architecture for enterprise scale companies. But it comes with all of those orchestration and pipeline problems. It's like, well, somebody updated the data yesterday and didn't tell us, so we didn't run our job, and now it's out of date. That happens, or it broke, it didn't run, or whatever. So all of those things happen all the time.
Maybe take us home. What's number 5? I know it's warehouse related. It's related to sizing of the warehouses and
and this may be a knowledge issue, but if we look strategically at what all of the cloud databases are doing, right? So the 3 we've been talking about for sure is that they're decoupling compute and storage, right? And so, but compute is even getting divided into smaller segments. So you might have a SQL compute engine, and you might have a Spark or a Python or some other runtime engine, right? So Databricks does that. Snowflake does that. BigQuery does too now. So that being said, the old worlds, like if you come from SQL Server or an AS400 or whatever, like I did, you had one environment essentially. So you were running a place, and then you'd have to get another one if you wanted a different environment. That's no longer true. And so customers that are aware of that get savvy about, hey, I think this compute should run maybe in a different size engine than this other compute, right? And as soon as you start doing that, you start to get some more fidelity into what you're doing and how you're spending your money. The unfortunate side effect, though, of that is that you then need to put controls in place that sort of say, well, am I actually using the compute effectively or not? So if I create a separate warehouse for every single query, like in Databricks, for example, and I just use a different one, or a SQL compute engine for every single one that's different, it's going to cost me more than fully utilizing maybe 2 of them. So then you start to get into this scenario of well, wait, I really want to understand how each query and how each pipeline is running and how much it costs me. But at scale, across maybe hundreds of pipelines, I don't know how to manage that. I need that observability and that management capability of all of that compute. So I call that warehouse fidelity, in that you want a lot of fidelity in your warehouses. You in general, a single warehouse doing all of your workloads is not the optimal solution. Neither is having one warehouse for every single job you're doing either. That's not going to be optimal either. Somewhere in there is going to be a place where you're going to have the right number of warehouses that are packed with the right number of jobs, and you're going to be intelligently consuming the credits of whatever platform you happen to be on. And you're going to get the outcomes you want, and then you're going to turn the warehouse off when you're not using it, so it's not costing you anything. So at Ascend, we kind of view that, we like to look at that from a FinOps perspective of hey, let's have warehouses that are tied to pipelines so that you can see how much each pipeline is costing you. But let's manage it for you so that there's no burden there. And then let's utilize that. So we're doing a whole bunch of parallel work. Let's pack the warehouse as best we can with the work we have. And then when we're not using it, let's turn it off for you. And so you kind of get your cake and eat it too. You get this ability to tune the warehouses for the right workloads and the right volumes of data and things for the environment you're in. But then you also get to look at and you get to see, well, which pipelines cost me the most? And do I care? Hey, this is my least, I make no money from the customer, yet their pipeline costs me the most. Why is that true? Or maybe this customer is the most lucrative and their pipeline costs a lot. I don't care. But getting the visibility into that is really, really important. But then being able to manage it and operate it is really where the key lies. So it's a great idea until you can't do it. So having some tooling that really pulls that together is the solution to that problem. At small scale, individual devs can do that. But again, I think that's something that the cloud vendors are driving toward. You see them in the features being able to do that. It's where their revenue comes from. So I'd be skeptical that they're actually helping you as much as they want you to think they're helping you. But having some tools manage that is really the key to avoiding the transgression of spending too much just because you can't manage more than one warehouse.
I saw a tinfoil hat appearing out of nowhere when you were talking about that. In general, I I know oftentimes it's probably like, again, it depends, it's the customer's use case and stuff, but are there any like rules of thumb that any customer, anyone, any organization should take into account when they're deciding on the appropriate data warehouse size for specific workloads? Does Ascend have their own kind of custom, like, just way that they look at it in terms of types of workloads and associated warehouse usage?
So we do have some analysis we've done. So we have some opinions around that. But because we open up the observability bucket and we let you see, like, how is this actually, how much is this costing you, and how are these workloads actually being managed by your cloud vendor, and do you actually care about it? And then we let the customer decide. So it's really easy to then go into the tool and sort of say, well, wait a minute, I want to divide these workloads up because maybe internally I charge for them differently, or this warehouse is overloaded. So let's decide, should we make 2 or should we make it bigger? And we have some opinions around how that works depending on the cloud and the data and stuff. But really the key comes down to is being able to measure it. When it starts to become a surprise and you don't understand it, now in general you have a problem. So once you're looking at it, once you understand it, once you learn how to manage it, it becomes really something pretty easy knob to turn, as long as you have software that's helping you do it. I don't know, Matt, what do you see, Matt? I mean, you must see all kinds of stuff.
Yeah, I'd say the right sizing question is something we see quite a lot of at our side at DoiT as well for all main data warehouse types. So with Snowflake, as you mentioned, you've got the sizing of your warehouse, but also how long the warehouse is up for, which you mentioned Ascend having the tool which automatically stops a warehouse at the end of the query. That's important to educate the customers in terms of when a warehouse should be stopped at the end of your processing. So using what Snowflake gives you there. But also on the right sizing perspective as well, we often see customers that have maybe scaled a warehouse too large, or they're having problems with the workloads because the warehouse is too small and it's being overutilized. So we do see both perspectives. Often we find that isolating workloads can be good, but not doing it too much. Like, you don't want a warehouse for every set of codes that is running in Snowflake, but at the same time, you don't want to overload your analytics warehouse with visualization queries maybe at the same time if you can't cope with the problems that are associated with your dashboards crashing. So that can be another thing we see quite a lot, where people are using visualization tools with a data warehouse in Snowflake. And on the BigQuery side as well, you've got the same questions with slot reservations, where again, there's the new BigQuery autoscaler that we spoke about in episode 1 of this podcast. And again, there's scaling decisions to be made there in the BigQuery side in terms of making sure your capacity is good enough to handle your workloads, but not too large in terms of wasting unnecessary costs. So we see similar decisions with BigQuery. And then on the Redshift side as well, we have a lot of Redshift customers that are still using provision Redshift clusters. And yeah, again, it's a similar decision there in terms of managing compute usage. And from our side, we've got many experts who can look through Redshift, the Redshift environment for our customers, and see exactly how we think it should be sized. So it's something that we help a lot with, and a problem we see every day.
Yeah, I think this problem falls in the bucket of the demand-based pricing. Like, people want to know, like, oh, how much is it going to cost me, like, to move into Snowflake, for example? It's like, well, like, you can look back at your costs, right? And if you have the right level of observability and the right level of granularity of that, then you can start to tune against it. And I think this particular topic is very highly weighted toward backward-looking things. You can make some assumptions and you can do maybe some predictive work, but you can't really predict how it's going to operate. The best thing you can do is have a stable environment that's partitioned and like scheduled properly, and then evaluate it every week or month or quarter or whatever cycle you need to evaluate on, and then make effective changes from there to adjust the cost if you actually need to.
Just to wrap this up, like you mentioned observability is, just even seeing what jobs are running, and that just prompts the question. It's like a FinOps. It's just in FinOps, just being aware is like almost half the battle, because then you start asking the questions like, do we need this running? Is that good? Is that bad? Some questions that don't come up immediately. With BigQuery, for instance, you have head of data engineering, head of BI, generally not aware of what their analysts are doing or what the people who are actually running the queries or executing the jobs are doing, and sometimes just even being able to easily see all that and click through, and that's half the battle. And I'm wondering, I'm more familiar with the query side of things with BigQuery and whatnot, but I'm wondering if when it comes to data pipelines, is there that same problem where many managers are just not being aware of what's running, where things are running?
Yeah, I mean, I think that's a really, really common problem. I think in particular, if you came from like an on-prem environment, your costs are essentially fixed, right? Like you have private data center, you have assets you're paying for, and you fill them up, and once they're full, you can't do any more, but you know what your cost is. And when you go to the cloud, that's no longer the case. So a lot of customers end up getting one bill from Google for BigQuery. And so the first question is, well, where did we spend our money? And so the first division might be, well, what's in non-production and what's in production? It's like, well, that's logical. Let's figure that out, right? But then as soon as you do that, it's like, well, within each one of those environments, it's like, is this money valuable or not? Like, are we actually spending the right amount on these environments? And that's where the observability comes in. And I'm a fan of more granularity, the better, because then you get more decision-making power over how to manage it. I think you can get a little crazy with it, but in general, I think pipeline, end-to-end pipeline costing is probably the right level to do it at. So if you have, hundreds of pipelines, understanding how they actually cost out is super valuable. And then your CTO, your CDO people who are, maybe hearing about these invoices from the finance people can have some intelligent answers for them too, around like, hey, yeah, we spend, 50% in non-production and here's why, right? Or we spend, 90% in non-production, which I have actually seen, and here's what we're going to do about it. So I think observability is a key to a lot of these optimizations in the cloud for sure. I mean, Matt, you see customers with great reports spending too much money. I don't know.
Well, I was going to mention one thing we offer at DoiT is we actually like to, from the BigQuery perspective, we can split out the customer's workloads per project. And from that, we like to give the customer information on where they may be spending money. So in terms of like a customer might have a look at projects where they're running analytics queries against BigQuery for the BI side. And they might have a data warehouse project, so we can split up customers' workloads by project to something that's useful to see in terms of where the money's being spent. And we also often look at like the most expensive users, because sometimes there can be a rogue service account perhaps that's executing pipelines that don't need to be run. These are very common problems we see in terms of how the workloads are being run and where the costs are being spent where they perhaps shouldn't be. And as you say, maybe in non-production you might get the odd rogue user that's running a few too many spinning up the Snowflake warehouse too often in Snowflake. That be a lot of intricacies like that can get missed. So observability is vital in these circumstances.
So lots of customers will overreact too. They'll look at like a single bill and be like, oh, BigQuery's too expensive. Let's go to Databricks or something, right? And somebody, this other vendor is like, oh, it'll run cheaper here for sure. But if you didn't know where it came from, the side effects are not going to be well done. And then I personally would want to know, if I was like moving workloads around, like, what do I expect to be the cost to be? Is it going to drop by 3%? Well, that's not worth it. Or is it going to drop by half, and why? Like, what is it about the other environment that's going to drop it by half? And can I optimize my environment to get close to that? So like, it all comes back to having the numbers and the visibility into what it is you're trying to do. And then you can make intelligent decisions around amplifying what you're doing today or to changing tactics. So
it sounds like a great sales pitch for FinOps. I mean, this is exactly what we try to educate our customers on all the time is you cannot make an accurate decision or a reliable decision if you don't know what the data is, if you don't know what you're talking about, right? And that very first thing, getting down and in the FinOps, we call it the inform, getting through and having that visibility, the transparency on your data and understanding what the hell's going on is a huge step forward for that. So good to see that's coming out in a few different products as well.
Yeah, well, maybe that's a great next podcast to do in a few weeks or month. Let's talk about FinOps.
We're doing one next with your CEO on Gen AI and data pipelines.
Oh, nice.
Or
that'll be awesome.
Data engineering. I think
be awesome.
I think that just about wraps things up here. John and Matthew, thanks for joining. Everyone, thanks for listening to episode 5. Hope to see you in the next one, especially if you're a data engineer. We're going to be talking about Gen AI's impact on data engineering with the CEO of Ascend.io, as well as our own subject matter expert around Gen AI. But until then, we're signing off. Have a great rest of your day, everyone.
Thanks.